Have you ever stopped to think about the stories behind all the science we learn? I mean, it's so much more than just a bunch of facts and figures, right? It's really this incredible collection of stories. Stories about curiosity, about looking at the world a little differently, and about those amazing aha moments that literally changed everything. So today, we're going to take a journey through some of the greatest stories of discovery, and we're using a classic science textbook as our guide.
So here's the plan. We're going to kick things off with a famous splash in a bathtub. Then, we'll see how scientists try to organize all of life itself. After that, we'll journey right into the heart of the atom, feel the power of some invisible forces, and finally, uncover some of the amazing secrets inside our own bodies. And then we'll wrap up by thinking about your own journey of discovery.
You know, sometimes the biggest breakthroughs in science don't happen in some fancy high-tech lab. Nope. Sometimes they happen in the most random places, all sparked by just a single moment of brilliant insight. And this has got to be one of the most famous stories in all of science. Just try to picture it. You're the Greek scientist Archimedes, and the king has given you this problem that seems totally impossible to solve. The answer doesn't come to you while you're poring over scrolls. It hits you in the bathtub. As he steps into the tub and sees that water level rise and spill over the side, boom, it all clicks into place. And the story goes he was so excited he leaped out and ran through the streets shouting, "Eureka!"
So why was a little splash of water so important? Well, that simple observation was the key to understanding buoyancy. It became this fundamental principle of physics that explains everything from why you feel lighter when you're in a swimming pool to how these gigantic, massive steel cargo ships can somehow float on the ocean. All of that from one moment in a bathtub. Amazing.
Okay, so those eureka moments are awesome, right? But a huge part of science is also about the patient, careful work that comes after. It's about taking everything we see and trying to organize it to make sense of this incredibly complex world. It's all about finding the hidden patterns in nature.
Now, what I love about this is how it shows that science is basically a conversation that spans centuries. You had Carl Linnaeus start things off with just two kingdoms, plants and animals. But then, as our tools got better and we understood more, scientists like Haeckel and Copeland kept adding to it, and it all led to Robert Whittaker's five-kingdom system back in 1969. Every single one of them was building on the work of the person who came before.
And this whole idea of classifying things goes all the way down to the chemical level. So take milk and water. At first glance, they seem similar, right? But milk is a mixture. Its parts are just kind of hanging out together, and you can change the recipe. Water, though, water is a compound. Its hydrogen and oxygen are chemically locked together in a super specific ratio, and that creates something with totally new properties. And get this, hydrogen is flammable, oxygen feeds a fire, but when you chemically bond them to make water, they put fires out. How cool is that? That's the power of a chemical bond.
All right, so we've organized the life we can see. Now let's take a journey into a world that we absolutely can't see. We're going to shrink way, way down and explore the fundamental building blocks of, well, everything.
Way, way before we had powerful microscopes, ancient thinkers were already wrestling with what matter really is. Back in the 6th century BC, the Indian philosopher Kanad came up with this idea of paramanu, these tiny, indestructible particles. And around the same time over in Greece, Democritus was calling them atoms. I mean, that is just an incredible leap of pure imagination.
Now, let's fast forward a couple thousand years, and, well, our picture of the atom has gotten a lot more detailed. We now know the atom isn't indivisible at all. At its very center, you've got a dense nucleus made of positive protons and neutral neutrons. And zipping around that nucleus are these tiny, negatively charged electrons. This elegant little structure is the foundation of all of chemistry.
Okay, so not everything that shapes our world is something you can actually see. Some of the most powerful and fundamental forces in the entire universe are completely invisible, but we can see their effects all around us every single day.
The textbook has this really simple but kind of mind-blowing experiment. You just float two magnets in a tray of water, and as you bring them closer, they'll either snap together or just dance away from each other, moving almost like magic.
Seriously, think about that for a second. There's nothing physically touching them. So, what in the world is making them move? How is that force traveling through the empty space between them?
The answer? A magnetic field. It's this invisible field of force that surrounds the magnets. And this non-contact force is a fundamental part of how our universe works. It's responsible for everything from a tiny compass needle pointing north to the giant electric motors that power our world. And here's another invisible force you're dealing with at this very moment. This number represents atmospheric pressure at sea level.
That is the crushing weight of the entire column of air above you pressing down on your body from every direction. The only reason we don't feel it is because we've lived in it our entire lives. But it's always there, a silent giant.
All right, for our next step, let's turn that scientific lens inward. Some of the most important discoveries in history haven't been about distant galaxies or tiny atoms, but about this incredible machine that we all live in, the human body.
You know, understanding our bodies can literally be a matter of life and death. When it comes to something like a heart attack, these symptoms right here are signals you should never, ever ignore. Just being able to recognize them is the first critical step toward getting help fast, and that can make all the difference.
And if you ever do find yourself with someone showing those symptoms, science has given us a clear, life-saving plan. These steps are a form of first aid called compression-only life support, or COLS. Following them can keep blood pumping through the body and dramatically increase a person's chance of survival until the professionals arrive. This is knowledge that can truly save a life.
And here is another absolutely life-saving discovery. Before the year 1900, blood transfusions were just a deadly gamble. Doctors had no idea why some worked and others were fatal. Then Carl Landsteiner discovered the main blood groups, and that changed everything. It made safe transfusions possible.
His work led to this crucial piece of knowledge. If you have type O blood, you're what's called a universal donor, which means your blood can be given to pretty much anyone in an emergency. And if you have type AB blood, you're a universal recipient. This simple but brilliant discovery is the foundation of modern blood banks and emergency rooms everywhere.
And hey, if you're ever thinking about donating blood, here's a pretty reassuring fact. During a normal donation, only about 350 milliliters of blood is collected. And your body is so amazing that it replaces the fluid part of that blood in just 24 hours. A small act that your body recovers from so easily can be a literal life-saving gift for someone else.
So we've journeyed all the way from ancient Greece to a modern hospital, and our guide the whole time has been this spirit of scientific curiosity. And you know what? That spirit isn't just something that's locked away in an old history book.
The most important thing to remember is that science is not a finished book. It's an ongoing story, a story of asking questions, of really looking at the world and then sharing what you find. It's a story that's been written by countless people throughout history, and there are still so many blank pages just waiting for new discoveries.
Every single one of the great discoveries we talked about today started with a simple question, or a moment of just being curious. So keep looking, keep asking why, and stay curious, because you never know where